Hi, I'm Allison. I'm presenting work I did with my colleagues at Lexion, which is a startup that spun out of the Allen Institute for Artificial Intelligence. We use natural language processing to automatically extract information from legal agreements. At Lexion, our clients need to answer high-level questions based on information found in contracts, like how many agreements do I have with this party, what's the value of each contract, and when do those contracts auto-renew. But contracts can be hundreds of pages long, and it's not always easy to find what you're looking for. So we can save our clients a lot of time by extracting this relevant information automatically. So you can think of the problem as starting from a contract, which is usually a PDF document, and getting to an answer, which is some text value you can find out from looking at the contract. But PDFs can be pretty messy. They have tables and images and handwriting. So we need to pre-process our documents into a form that's machine readable. And then we need a system to read the document and give us the right answer. And it needs to scale across lots of documents and lots of different types of answers. Most research focuses on optimizing that last step, the machine learning, but we actually found that iterating on the beginning part, the pre-processing, had a surprisingly big payoff for the overall performance of the system. By pre-processing, we mean when you start with a PDF, you're basically starting with an image, and you need to get it into a machine-readable format that a natural language processing system can understand. A lot of standard machine learning tasks are set up to work on raw text. Legal documents have a lot of tricky characteristics, like headers and footers that could trick a model into thinking they belong in the middle of a sentence. And they use a lot of formatting to separate the document into clauses and subclauses and even sub-subclauses. And you need all that information to be able to send the right text to a machine learning system. So we did some experiments to figure out what types of structural information are most helpful for recognizing these sections of a contract. Most modern OCR systems don't just give you raw text, you get what we call visual cues about the structure and formatting of the document. So we divided up the most common visual cues into 4 categories so we could see which type was most helpful. We looked at page layout features, where the text is laid out in different regions of the page. So is it on top or bottom or maybe all the way at the margin? Text placement features, so within a general region like the top of the page, where is the text placed? Maybe it's centered or right justified. Visual grouping features, whether text is part of a paragraph or in a table or grouped with other text in some way. And stylistic features, like whether the text is bold or underlined. To find out how helpful each type of feature was, we trained a baseline model without any visual cues, just raw textual features. And then we trained ablations that had access to each type of feature, and one that had access to all the features. We have all the detailed results of the paper, but to sum it up, using different combinations of visual cues above and beyond the raw text helps you recognize the different sections in a document and break it down into clauses and subclauses that have the answers to questions you're asking, and also recognize which parts are headers or footers that might break up a clause and confuse a downstream model. The results are most significant for footers, and we have some analysis of why in the paper, but all 4 section types we looked at had some improvement with 1 or more of the different types of visual cues. At Lexion, we use a full end-to-end system that incorporates these visual cues to pull out information from our clients' legal documents. And while we unfortunately can't share the details of the models we use, we did test our system against the existing state-of-the-art results on the Contract Understanding Atticus Dataset, or QUAD, and we showed improvement over both a rule-based system and a BERT model for 4 different extraction tasks. We're hoping our research sets the stage for some further research, not only on QUAD, but on different OCR systems and more creative types of visual cues. We really think it can pay off for legal documents especially, but really any domain with long and structured documents. Thank you.